Hello student, I am Dr. Bhanumati Panda, Associate Professor, Department of Applied Science and Humanities, ABES Engineering College, Ghaziabad. Today we will discuss about Fourier series. So we'll come to know what the Fourier series and why do we use Fourier series. Fourier series कहाँ use होता है, कैसे use होता है, what is Euler's formula and how to represent a function in terms of Fourier series. Basically, Fourier series is a trigonometric series expansion in terms of sine and cosine series only. तो जिस फंक्शन में पीरियोडिक फंक्शन होता है आई मीन जहां पे पीरियोडिक फंक्शन इन्वॉल्व होता है ऑन दैट केस लाइक हीट इक्वेशन इलेक्ट्रोस्टैटिक्स इक्वेशन तो इन इंजीनियरिंग फील्ड जहां पे भी हम पीरियोडिक फंक्शन यूज करते हैं ऑन दैट केस वी नीड द फोरियर सीरीज रिप्रेजेंटेशन ऑफ फंक्शन. सो what basically the Fourier series representation of function, what is a periodic function, we'll discuss about it, what the Euler formula will discuss about it, and how to represent a function in terms of Fourier series will represent today, right? So basically, as I have told you, if a function is periodic function, then only we can use the Fourier series expansion. So what the periodic function is, many of you know that what a periodic function, which repeats after a regular interval of time. Suppose a function, will say that a function f of x is said to be a periodic function, if f of x plus t is equal to fx. Many of you know it. What is t? T is the smallest period of the function, smallest period, which is also called as the fundamental period. इसको हम fundamental period भी कहते हैं. Fundamental period. बहुत सारे सिंगल वैल्यूड फंक्शन है इन मैथमेटिक्स जिसको हम रिप्रेजेंट करते हैं लाइक a0 प्लस a1 cos x प्लस a2 cos 2x and so on. And similarly, plus b1 sin x plus b2 sin 2x. इस फॉर्म में अगर हम रिप्रेजेंट करते हैं then we'll say that this is the trigonometric series expansion of the function, which will call it as a Fourier series expansion. So we'll discuss about what the Fourier series expansion is. Before going to discuss the Fourier series expansion, will let us know some formula, that is trigonometric formula. इंटीग्रेशन हमें चाहिए जिसको यूज करके हम प्रूव करेंगे यूलर्स of functions, right? So the first formula is, suppose we are taking the interval fx, we are considering a function in the interval c to c plus 2 pi. The period of the function can be find out. How to find out period of the function? That is upper limit minus lower limit. Upper limit क्या है आपका? That is c plus 2 pi, and what the lower limit is c. So the period of the function is 2 pi. Many of the function, you know that sin x, cos x, these are the periodic function of period 2 pi because it repeats after the interval of 2 pi. ये आपको पता है पहले से. So before going to discuss, suppose हमें कुछ फॉर्मूला जानना है, ये बेसिक फॉर्मूला जो आपको याद रखना है और फोरियर सीरीज के लिए बहुत जरूरी है. सो इफ द इंटीग्रेशन इज लाइक c to c plus 2 pi, right, sin nx dx, then the value you can find out, the integration value will be minus of cos nx divided by n, limit c to c plus 2 pi. You know that is minus of cos n, x के जगह हम सब्स्टिट्यूट करेंगे c plus 2 pi minus of cos, we can find out this value, that is cn, right, divided by n. Then the value will be equal to, you can find out that is cos A cos B. We can write that is cos A plus B is cos A cos B minus sin A sin B, right? So we can write this is minus of cos of A plus B. So cos C and cos C 2n pi minus sin NC and sin 2n pi minus of cos of Cn, right? So this value, we know that this value will be equal to 0. Cos 2n pi is equal to 1. So this value is equal to 0. So similarly, we can write that is C2 C plus 2 pi cos nx dx. The value is also equal to 0. Similarly, the formula is that is C to C plus 2 pi. If it is sin mx cos nx dx, the value is also equal to 0. Right? The formula number 4 is similarly C to C plus 2 pi cos nx cos mx dx is equal to 0. And we can also write that is C to C plus 2 pi cos square nx. The value will be equal to pi. You can find out the integration. So C to C plus 2 pi. Similarly, sine square nx. You know how to find out the integration. This value is also equal to pi. Right? Also, we can write the value that is integration of, I'm using here the indefinite integral, e to the power ax sin bx dx. ये सारा फॉर्मूला हम यूज करेंगे for the Fourier series representation of function. We can write it e to the power ax divided by a square plus b square. The value is a sin bx minus b cos bx plus the integration constant c. Similarly, we can find out e to the power ax cos bx dx. The value will be equal to e to the power ax divided by a square plus b square. The value is equal to a cos bx plus b sin bx plus c. The most important formula, that is, we'll use this, the Leibniz formula u(v)dx, that is u v1 minus u dash v2 plus u double dash alternatively चलता रहेगा minus u triple dash v4 and so on. What this u dash represent? U dash means that will be du by dx, differentiation with respect to x, and what the suffix n represent? This is the integration of the function. So these are the formula which we need to find out the or to evaluate the Euler's constant. Now we'll see that what the Euler's constant is. Now we'll come to the Fourier series representation of function or Euler's constants, किसको हम कहेंगे. Now any function, if fx a function, we can represent the function, the Fourier series of expansion, the Fourier series expansion of function fx in the period c less than x less than c plus 2 pi can be represented, can be written of the form that is fx is equal to a naught by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity Bn sin nx. Now these constants a0, an and bn are constants which we need to find out, and these constants are called, ये जो constants हमें मिल रहा है are constants and is called and are called the Euler's constants. These are called the Euler's constants, or we can say that constants, or we can say that these are the Fourier coefficients, right? Fourier coefficients. Now, how to find out this constant? Because if a function, suppose the function fx will be given to you, we need to find out the value of a0 and an and bn. ये तीनों constants की value चाहिए to represent the function in terms of Fourier series. Now, how to find out the Fourier coefficients or Euler constants? ये हम कैसे find out करेंगे? Now, fx is equal to, suppose this is given that the function is given fx is equal to a0 by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity bn sin nx. Suppose this is the Fourier representation of function. Now, if I'll integrate both sides from the interval c to c plus 2 pi, right? C to c plus 2 pi fx dx. Then a0 is constant, so a0 by 2, you can take it outside. That will be c to c plus 2 pi, that is dx, right? We are integrating, and summation integration c to c plus 2 pi, summation n varies from 1 to infinity an cos nx dx plus c to c plus 2 pi, summation n varies from 1 to infinity bn sin nx dx, right? So we are integrating both sides from the interval c to c plus 2 pi. Now we have already used this formula, that is integration. We can take it outside because these are the continuous function. So summation को हम बाहर ले सकते हैं, c to c plus 2 pi cos nx dx. Already we have used this formula, और ये हम formula में represent कर चुके हैं. This value will be equal to 0, and this is also sin nx is also 0. So we are getting this value, that is 2 pi, right, into c to c plus 2 pi. So x upper limit minus lower limit into a0 by 2, right? So a0 you are getting, that is 1 by pi integration c to c plus 2 pi fx dx. So this is the constant term of the Fourier coefficients. We are getting the value of a0. Similarly, we can derive, or we can find out how to represent an, the Fourier coefficient an हम कैसे represent करेंगे? An will be, similarly we can find out the value of an is equal to, we can write here the an, we can find out if we'll multiply both sides by cos nx dx, we can find out this is c to c plus, we can write this is c to c plus 2 pi, right? This is your c fx cos nx dx, cos nx dx. Similarly, we can find out the bn will be c to c plus 2 pi fx sin nx dx. So these are the Fourier coefficients, right? And in the next lecture, we'll discuss how to represent a function in terms of Fourier series expansion. So in this lecture, we have discussed about why do we need Fourier series representation of function, और Fourier series हमें क्यों जरूरत पड़ती है. इंजीनियरिंग फील्ड में हम फोरियर सीरीज का कहाँ यूज करते हैं. दूसरा, व्हाट द फोरियर कोएफिशिएंट, व्हाट आर द सम फॉर्मूलाज. इन द नेक्स्ट वीडियो विल डिस्कस अबाउट how to represent a function in Fourier series representation, right? So these are some references book we have taken or we have used, right? Thank you.